Hopefully everybody got their Ubuntu ISO downloaded. Let's go ahead and move on to our lab system setup instructions. Again, the verbiage at the front explains kind of what we're doing. You're expected to already know how to use Linux. We aren't going to do a lot of commands on the command line today. So do look at that tutorial cheat sheet before next week and make sure you're up on that one. Scripting is something we can do with anything that allows us to save commands in a file. These files are text files. They are plain text files. So they cannot be a Word document or an RTF rich text format or any other formatted text file. If it has fonts or colors in it, it is not a shell script. It's a document. Okay? Shell scripts are plain text only. And of course, we need a way to run our commands. And for that, we use a terminal window, which allows us to enter text commands and get text output. Okay? Those are the two minimum things that you need. You could actually do all of your shell scripting right on the console of your machine. However, that's a really hard way to do things. The console is not resizable. You can't make the text bigger to make it easier to see. You can't expand it so that you have longer lines or more of them. Not good. So for this, we're going to use a Linux desktop. Okay. We've chosen Ubuntu simply because it gets used in other courses as well. And rather than learning new distributions of Linux for every course, we try to keep it to just one. I didn't actually select Ubuntu myself. It was being used in other Linux courses when I started teaching at the college, for a long time ago. So we've simply continued with it. Is Ubuntu the best Linux? Well, if you work for Canonical, yes, because it's their product. Otherwise, there is no best Linux. It's a good base one because it has lots and lots of tools available, and there's a great many people using it, so there's lots of online resources that can help you with it. Okay? In truth, any Linux machine will be fine for doing scripting. Okay? We're going to use our VM to do this because when we start doing scripting, we're going to be running commands in an automated fashion. And if for some reason you create commands that can harm your system and you run them automated, if this is your main machine, you can wipe it out with one command. Not good. So I recommend a VM. Okay. And of course, you can run it anywhere else you wish. VM can be on your own computer. The VM can be on a remote machine. You could create a VM on something like Amazon Web Services using a virtual machine on their site, a hosted site, and do it on there. And it would be just fine. The biggest issue with that is to use the GUI, you're going to have to use some kind of remote desktop. And you might find that that's a little bit slow and stumbly to use. It also means that you can't use it if for some reason you can't access the internet. So it has that downside. There is a note in here about using remote access to a Linux machine of your own running on your home network. That note was written, of course, when we ran our classes in an actual classroom at the college. Presumably you're at home now, but whether you're at home or whether you simply have access to your home network through a VPN or something like that, that's fine too. You can go ahead and do that. If you have a spare PC and you don't want to bother with a VM, you can actually install Linux on its own PC and use a remote desktop to access it. Okay? You can also do it on something like a Raspberry Pi if you like. We are going to be using the desktop version of Linux. Okay, so I've mentioned that a couple of times. We are using the desktop specifically so we can see what script writing tools look like. Not because it's required for the scripts themselves. Okay, so kind of once we get past today, if you're finding that it's hard to use, you could switch to a user version, server version if you want, but of course you'll have to reinstall everything. We're doing the labs together. What that means is I'm going to demonstrate things using my screen here on WebEx, and hopefully you're doing them at the same time on your own machine, so that you can try the things I show you. And if you have a problem making it work the way that it's supposed to, you can ask the question right away and get an answer. So you want to make sure you've got reliable access to things so that you can run them. All of our scripting is being done as an ordinary user. We do not need root for most things. Now, the biggest exception to that, of course, is installing the system in the first place. So today's activities, we'll be using sudo a fair bit to get root permission to do things. But once we kind of get past that, scripting itself is not a root activity per se. You may well need root for specific commands that are in your scripts, and you'll always have to decide whether to actually put the sudo in the script or requiring the person running the script to use sudo for the entire script. That's going to be very task dependent. Okay. Since I'm recommending we all use the latest version of Ubuntu, the version of bash you're using should not be an issue for anyone. Should be just fine. If you want to check what version of bash you have, the command is bash space _version. So if I were to go ahead and get a terminal type window here, I happen to be using a Mac. A Mac is a Unix-based machine. So it's going to have a lot of Unix tools, including things like bash, which actually wasn't created for Linux. It came from the Unix world. There are lots of things that are the same between Linux and Mac OS. Bash is one of them. So if I were to run bash _version, we would see that the version of bash that's running on my Mac is version 5.0.7. If I were to use SSH to remotely connect to a machine that I happen to have running in the basement, which happens to be a Linux machine, I can go ahead and say bash _version there, and I'll find that that machine is running bash version 4.4.20, so bash version 4. That's because that one happens to be a Ubuntu 18 machine that I just haven't bothered to upgrade. This is why we mentioned that shell version may matter to you. Again, it's not as much of an issue for bash. It's more of an issue for PowerShell, but you may encounter different versions out there when you're using it. All right. Our primary tools that we're going to use in this course, we're of course using Linux with bash. We're going to be using Atom, which is an editor. It was developed for use on the web. It was actually intended to be embedded inside web pages. If you've ever been on a website that offered you the opportunity to open and edit a file, chances are it's actually using Atom on the server to do that. Okay? And of course, we're going to use the Git tools and the github.com website as the back end for that. We're going to build a tool into Atom, aside from Git, called lint, using a package called the linter shell check, to look for common syntax and typing errors so that as we are creating scripts, we can right away see if we've got errors in our scripts without even having to run them. So let's go ahead and get ourselves started here. Our first step is to install Ubuntu Desktop Linux to make sure it's up to date, and then start a terminal window. I'm going to guess that most of the people in the class have a Windows machine. There are going to be some that have a Mac. I, of course, am running on a Mac. If I simply run the VMware software on my Mac, the folks running Windows are going to see slightly different things. To try to avoid that confusion, I am going to try to do well, a bit of an experiment. I have VMware running on my machine. If you don't already have VMware running on your machine, you'll need to get it installed. That'll be your first step. I have quite a few virtual machines running on my system, as you can see. Among them, I have a Windows virtual machine. It's a fairly generic installation of Windows. I'm going to attempt to run VMware on there for our purposes. I may also try a remote desktop. And as a matter of fact, since I don't have VMware yet installed, we won't take the time to install that now. I'm going to start with a remote desktop, and next week I'll see if I can get it running on my VMware machine. In terms of creating a Ubuntu machine for the purpose of our course, I'll do the demo real quick first on the Mac so that we can see, and then I'll try remote desktoping to a Windows computer that I've got running down in my basement that should already have VMware on it, that we can try creating the Windows version. So on a Mac, you'll open your VMware, you'll choose to do a new VM. You're going to be installing from a disk or image because we have our ISO for Ubuntu, hopefully already downloaded. We're going to select our ISO. The last one that I installed on this machine was the server version, which isn't what I want. So I'm going to choose to use another disk or image. I'm going to go to my downloads folder where I just downloaded the Ubuntu 2004 desktop and choose that one. Make sure it's selected here. Click continue. We're going to do an easy install because for scripting purposes, the details of the Linux we're installing are not a big deal. So I'll go ahead and create it with the default account. I will put a password on it. I don't need to share anything over from my Mac. So I'll continue. It's going to give me my VM with a 20 gig drive, 2 gigs of RAM, blah, 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 blah. It's going to share the networking with the Mac. That's fine. All the details are just fine. I'm going to say finish. It says, what do you want to call this? I am going to call this my Comp 2101 Summer 20 semester VM. And I'm going to say save. And that will create the VM and it will actually start it running from the ISO. This, by the way, will be my personal first install of the 2004 desktop, so this could be interesting. I've done the server a few times now, but the desktop, this will be my first one. They've changed everything over to the Squash FS. Interesting. Did Windows just make that sound on everybody's machine? Did everybody hear the ding, 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 ding? Good. Thank you. Never quite sure with WebEx what it sends through and what it doesn't. All right, while that Ubuntu installs on my Mac VMware, I'm just going to go ahead and connect up to this Windows machine I have in the basement. And we'll do the same thing in Windows. It's a fairly generic Windows machine that I have there. It's got a few little tools for this, that, and the other. For the most part, I just use this machine for running Warcraft. So none of that should interfere with anything we're doing. We should be able to just quit all those things. Right. So VMware, the console for VMware looks slightly different in Windows, but it's the same basic thing. You have a list of VMs and you can make new ones. So let's create a new virtual machine. We're going to make a typical machine. Click next. We need an ISO, so we're going to select ISO. We're going to have to go find an ISO to install. I don't think I've actually downloaded the Ubuntu desktop on here yet, so let's go to Ubuntu. Let's click on download. Let's click on the desktop 2004 LTS, and it should download. Hopefully relatively quickly. Oh, and just while that's downloading, let's take a look back and see how our Mac VM is coming. It says it's still installing. Very good. Hopefully everybody has their machine either installed already or is installing as we're doing this. Again, if you follow along while I'm doing this, it will help you to see whether or not things work the way you expect and to be able to ask questions as they go. My ISO download has just about finished. There, it's done. Good. So I can now choose Browse. It will have gone to my Downloads folder. There it is, Ubuntu 2004. It says it has detected that it's a Ubuntu. It's going to be done with easy install. That's fine. We'll click next. I guess Windows doesn't know who I am. You can put anything you want in for your name, your account, etc. None of that matters for our purposes for this course. This machine will be Comp 2101 summer of 2020. I'm going to store the virtual disk as a single file because it increases performance slightly and I'm not running a fat file system. The hardware looks fine. It's pretty much the same defaults that it had on the Mac. I will choose finish. And it has made me a virtual machine. So that's when it's going to start up now and start loading and running the Ubuntu install. This little thing across the bottom, the stripe that says, oh, by the way, we're running in this window, blah, blah, blah. Yeah, okay, no kidding. I'm just going to click X and get rid of it. All right, while that starts running, let's have a look back. And see how our VM install is going. The VM actually finished installing and it's finishing its first boot and installing some software automatically on the Mac version of the VM. Hopefully the Windows one will catch it fairly quickly. Is showing both versions of this, the Mac and the Windows version, helpful to people? Am I boring everybody? If you have a thought or an opinion on it, if you could put it in chat, that would be great. And I can summarize that for the group. The Mac version is finished. It started first. So let's go ahead and get logged in. No, I do not want to connect to any online accounts. I'm going to skip this. I am going to skip live patch. Don't need it for our class. I'm not going to send system info to Canonical because what I'm doing isn't going to be helpful to them anyway. I don't need location services. My VM doesn't know where it is anyway, so I'll just click next. And I am ready to go and I will click done. Now my VM has been installed. So on the Mac, you'll notice that the main VMware window, which is this one showing all my VMs, and the console of my virtual machine, is actually quite similar to the Windows version of that, where your VMs are listed and the console shows. Okay. In the Mac version, One of the features I personally consider to be nice, and it depends on your personal preferences, is that I don't have to do, as a matter of fact, I don't normally do any work hiding in this little console window here. Instead, I would actually put this away and use this window to do my work. Okay, where the virtual machine is in its own separate window. And one of the nice things about that is, of course, I can resize that window to get more resolution on my screen, and I can make it whatever arbitrary size I like. Whereas the console window in VMware, by default, is a little bit more fixed and fussy in its configuration. There are ways of changing it. It's a bit of a nuisance. So my Ubuntu machine has installed. It says there's new software, etc. I'm going to say remind me later because I don't want to take the time right now. You should keep your machine up to date. We're not too worried about it for the purpose of what we're doing right now. I'm going to set this machine aside for the moment and go back to the Windows one to see how it's doing. I want to get both machines to the same point so we can see any other differences between the Mac and the Windows version. And then we're going to go down to using just one machine to do the scripting. What's in the chat? Has anybody got questions? Push deep. Your VTX is disabled. Okay, so your VMware won't work without VTX. It's a processor feature that allows virtualization. That is controlled in your BIOS. So you will have to look online to find instructions on how to get to the BIOS settings for VTX on your particular computer, on your specific PC. And you'll have to follow those instructions to turn on VTX and then reboot Windows and give it another try. Chris, you're working ahead and you are having an issue with clicking on the bash folder. Can I ask you to hold off just for a bit until we catch up with you, and then you'll see it on my screen and hopefully it'll answer your question? Thank you. You will have to catch up afterwards. It'll take you a little time to get your BIOS changed and get your VM created now. All right, the Ubuntu is installing here. We're going to leave it running on the Windows one. There's nothing magic about doing it on Windows versus anything else. Once the VM is installed, it doesn't matter what your host platform is. All of our work is actually going to be done in the VM on Linux. Okay, so I'm going to just go ahead and put that one away for the time being and go back here. All right, so the instructions in the lab we were following, we go back here, were to install Ubuntu Desktop Linux with an easy install is fine. We've done that. Be sure to update the software on it. I'm going to skip that and do it later because what we're doing right now doesn't depend on the updates. We're going to need a terminal window, it says, so start one. All right, so in our VM machine, we're looking at the Linux desktop. So to start a terminal window in Linux, there's a number of different ways. The easiest way off the top is to click on the little matrix of buttons at the bottom left for showing applications. Scroll down and click Terminal. You'll get a terminal window, which looks quite similar to the one that I originally had running on my Mac earlier, because it's really the same application. Now, when we start this in Linux, we get our terminal window. It is completely resizable. We can make it whatever size we would like to make life easier to work with. We can make the fonts bigger and smaller, etc. All good and all useful to us. When we started this application, you'll notice we got an icon in the taskbar to the left, what they call the launcher. Okay, I'm in the habit, since I'm going to be using this terminal a lot, I will right-click on that icon to get a menu, I will choose Add to Favorites. This is the equivalent of Windows saying Pin to Taskbar. When I add that to my favorites, it means if I then later decide to quit my terminal or I've rebooted my virtual machine, I don't have to go find the terminal again. It stays here when it's not running, and I can click that to start it again without having to find it again. When it's running, there's a little orange dot next to it. If I were to right click and choose make a new window, so I've got two terminals running, I have two dots, so I can see how many of them I have going. I'm going to just run one right now. We said we wanted one, we have one, that's good. There are other icons in the taskbar. In particular, if you're on Windows and have a scrunched down console to work in, because you may have, all these icons will take up space on this launcher to where it's hard to see everything you've got running. And most of these we're not going to use this semester. So you might wish to take them off of there. For example, we're not going to use the LibreOffice Writer. If you right click, you can choose Remove from Favorites. Same with Rhythmbox, which is a music player. Same with Thunderbird, which is for doing email. I would leave Firefox there because you might find the browser helpful to have. I would leave the file manager there because you may find it helpful. And depending on whether you like to do your software updates with graphical utility or whether you prefer to do it from the command line, you might choose to leave the software tool here. And of course, also the help tool, up to you. So we have our terminal running. Here's the commands to do our update and upgrade. I'm going to suggest that you run the update now, even if we don't do the upgrade. The reason being, if there's something wrong in how your VM got built, this will show you because it tries to talk to the internet. And if you haven't configured your VM properly, it won't be able to talk to the internet. And this tool will tell you. If you've done everything right, you should go ahead and access the web repositories for Ubuntu, download update lists, and tell you if you have things to upgrade, and there will be. If that command doesn't work, if it says unable to resolve names, that means that you haven't built your VM properly. If you've used Easy Install, there's very little that you can mess up. If you did a custom install, it means that you've done something wrong with the network configuration if it can't reach the internet. All right, now that we know we can reach the internet and our APT software is updated, we can go ahead and install the software we need. We need a program called shell check, which is a syntax checker for shell scripts. It's a program that can go ahead and help us identify problems in the scripts we've created based on recognizing when they've been typed wrong. So let's install shell check. I hope everybody can read the text on my shared screen. Hopefully it's not too small or fuzzy for people. Thank you, Chris, for sharing that. Yes, your VM, if you did a custom config and can't reach the internet, it may be because you haven't configured NAT as the network interface to connect to. It may also be if you have DHCP disabled in your VMware for another class, which occasionally happens. So once shell check is installed, we now have a shell check program, which is a program that we can use to check and see whether there are syntax errors in our shell scripts. The next step is to install our Atom editor. So Atom is distributed in a different format. It's distributed in what's called the snap format. It's kind of like APT, but with a slightly different set of commands. And we're going to go ahead and install it in classic mode because the snap doesn't behave well in the sandbox right now, the snap sandbox. So we're going to snap install Atom Classic. And it will go ahead and download and install that. Okay, Atom has been installed. Sarthak asks, I am recording this? Yes, I am recording this. Or at least I started it recording and presuming it is still recording. I will publish the recording afterwards. So we installed shell check, we installed Atom. It's time now to configure Atom to use our shell check and also to connect it to GitHub. To do this, unfortunately, is a little bit of a nuisance. The folks who maintain the Atom software, I mean, unless they've updated it in the last month or so, have made a rather cranky installer. It kind of requires you to do everything in the right order or it doesn't work properly. So I've written out detailed instructions for us that gets everything done in the right order, but it's really important that you follow those instructions closely and do them fully and in the order they're given, or you're going to have trouble in Atom. Okay. So first step, start Atom. Well, Atom is an app that we've just installed, so we can go to our applications list, and we'll now see Atom is there. It's got the green one with the stylized Atom image. And if we click that to run it, it will start up. It may take a moment to start up. Do not be impatient. Don't start a second one. Wait for Atom to start. You'll know when it has finished starting because the launcher icon will show up. You are looking for the launcher icon before you touch anything. We're going to be using, well, I'm going to be using Atom frequently. So I want to make sure that it stays available. I'm going to right click on the icon in the launcher and I'm going to add it to my favorites list so that it stays there and is easy to find and restart again. That's also reminded me to wait for the icon so I know Atom has finished starting up. Okay. So we can start our Atom a couple of different ways. They're mentioned here. But once it has started, the first thing we're going to do is get rid of the default tabs. So Atom is a modern tool. It uses tabs to present multiple windows. There are 3 that start by default. Now, if you simply quit them, every time you start Atom, they're going to come back. So we need to take a quick look at what's in them. So in the main welcome tab here, it says, hello, this is Atom. We have a website. We're wonderful. Life's great. Blah, blah. There's a checkbox here. Show the welcome guide when opening Atom. Unless you want this to come up every time, uncheck that box before you quit the welcome tab. The tab for telemetry consent. It's looking for consent to send them your usage information or not. Pick one. It doesn't matter which. Pick one. Don't just quit the tab. When you pick one, the tab will go away and it won't come back. If you did not pick one, every time you start this tool, it's going to ask again. So you might as well give it an answer. And the welcome guide we don't need. We're going to choose to quit that as well, just so we have a nice clean Atom window to start with. So we've exited our default tabs. Now, on the Edit menu in Atom, we're going to choose Preferences, and then we're going to click on the Install button that we get. So on the Edit menu, we're going to choose Preferences, And we're going to click on Install, which allows us to install plugins and add-ons for Atom, give it additional capability. Atom is a modular tool. We can expand it very easily. The module we want to install is our shell check one, but it's not actually called shell check in Atom. So we're going to put shell check in the search box, and when it finds something called linter shell check, we're going to click the install button. So we're going to type shell check in the search box, and it's going to show us linter shell check, and there's an install button with a little download from cloud button. We're going to click that. It's going to sit there and do a little blue vibration thingy, and when it's done, it'll be replaced with 3 buttons for settings, uninstall, and disable. When you see those 3 buttons, it has installed. That's all we need to do with that. Now, linter shell check needs a couple of extra plugins, but they are automated. We do not need to go and find them. The first time we open a shell script that this module gets used for, it's going to prompt us to install the extra modules, and that's when we'll install them. So our shell check has been installed. The default theme is a dark theme with white lettering. Buttons look a certain way, menus look a certain way. The themes are changeable, okay? There's a themes button on the left in your Atom window. If you click on that, you can choose different themes. You could use dark, you could use light, and as you can see, it'll change what the screen looks like. You can make it look any way that you wish. You can change the settings for fonts and all kinds of things. You might wish to change it, you might not. This is the first time I've run this through WebEx. So I'm open to feedback on which is easier for people to read on my screen, the light one or the dark one. If you have a preference, could you please type it into chat, and then I'll go ahead with whatever people prefer for the most part. I see lots of votes for dark, a couple of for light. I'm sorry, it looks like the dark is the winner. We're going to leave it on dark. You, of course, can set your own any way you want. For mine, I'll leave it on the dark then, since that seems to be the one most folks would like. All right, we're done with our settings. We're going to quit our settings tab and fully quit Atom. So the settings tab, we're going to quit. And we're going to completely quit Atom, because unless we do that, it won't recognize that we've installed the plugin properly. We want to have it recognize that. The other thing is we're going to be connecting this to GitHub, and we don't have GitHub available to us yet. We haven't created our GitHub. So before we restart Atom, we're going to open a web browser, and we're either going to create a GitHub account, or if you're already a GitHub user, you can actually use your existing account and just make a new repository for this course. For demonstration purposes, I'm going to create a GitHub account to use for this, just so people can see how it's done. So we need a browser. I'm going to just do it in my VM. I'll use Firefox. We're going to go to github.com. If you have an account, go ahead and sign in. If not, we're going to do sign up. We need to create a username for this account. Let's see. It needs to be a name that they don't already have, and they have millions of users. So I'm going to call mine Comp 2101 Wednesday. As I'm typing this, you'll notice it tells me if this is available or not. So I'm going to go ahead and use that name. I need an email address for this. Let me think for a second. I created one last semester. Bear with me a moment. I'm going to have to create one. I do actually already have a GitHub account, so I can't use my normal email for this. Pretty sure I still have that account left. I do. That email account was comp2101-02 at onsorp.net. Each GitHub account needs to have a unique email address, which is why I can't reuse my existing one. As I say, if you already have a GitHub account, you don't need to make a new one. And I need a password for this. Well, that'll do. This text below where it's talking about your password should turn green when you've put in enough characters of the right types and so on. I don't need them sending me things. They don't use CAPTCHA, they use puzzle solve. I actually greatly prefer this. We're going to click verify. And I have to rotate, in my case, it's a dog, to make it horizontal. And click done. 8 seconds. Gee, that's not so fast. Create account. And I'm going to tell Firefox to save this. And now it's going to say, you didn't do that very good. You didn't have a very good password. So I'll do it again. Comp2101-02 at sonsorp.net. And it saved the password, but I'm going to change it to something else. How about that one? Verify. Done. 4.4 seconds. Much better. I'm sure somebody will beat that. Create and update. Oh, it still doesn't like it. Wow, I'm not coming up with very good passwords. All right. Since it's going to be saved in the browser anyway, it's time to face roll the keyboard. There we go. I have no idea what it is, but I'm sure it's fine. Done. Create. Update the saved password. Yay. I have a GitHub account. Hopefully everybody else does now too. I took long enough. What do I do? What do I do? I'm not interested in anything and I don't do anything. How about just complete it? So it has sent me an email now asking me to confirm my account. So over here in another window, I will go and check the email for that. My email has arrived. It's got a link for verify email address. I will go ahead and click that. Well, maybe I won't click that because it wants me to click it in another window, and that's not going to be useful. Let's see if I can paste and go here. There we go. All right. We've created an account. The first thing we need in our GitHub account is a repository, a place to put our files. We're going to be creating a repository. In the instructions, we've created our account. We're creating a repository, and there's a word for that, a short form called repo, R-E-P-O. So a repo is a repository. We're going to call a repository comp2101. In truth, you can call it anything you wish. All of the examples that I give in the lab instructions assume you've called it comp2101. So if you don't call it that, then everywhere in the instructions, like down below here and here and here, they all say comp2101, and you'll have to change it to the other name if you've chosen to call it something else. I'd keep it simple and call it comp2101. So we're going to click Create a Repository, the name, and yes, it's case sensitive, comp2101. It can be public, and it's really important to check this box. Initialize this repository with a README. And click on Create Repository. So that's going to create a storage space on the GitHub website to hold your files called comp2101. You can make as many files in there as you like. You can make folders in there. You can name the files anything you like. Comp2101 is the name of the repository itself. Okay? Okay. So we've made our repository. We're now ready to go to our Linux machine and create a duplicate or a clone of that repository on our Linux system disk. You can actually clone it to as many computers as you want, work on things on the computer, and send the changes back. So the idea is that GitHub is going to hold the master or golden copy of all your files. And you're going to use it as the place to keep them all. If your computer starts being slow or annoys you through the semester, you could sell it and buy another one and just make a copy of your repository, and you still have all your work. Your laptop can explode, can go up in flames, can get a virus, can be taken over with ransomware. All your files are fine. They're safe on GitHub. Okay? So to configure the machine to use GitHub, there's a couple of commands to do. Those commands are done in the terminal window. So we need our terminal window. And the commands are actually given here to save you the trouble of looking them up. Git is the name of the command line tool to configure and run GitHub from a terminal. It takes subcommands. We're going to be doing configs. We're going to do it globally. We're going to configure an option called user email and one called username. You're going to put in the email address that you used to create your GitHub account, and you're going to put your actual name on the second one. So in my case, it's going to be git config --global user.email. And the email address I used was comp2101-02@zonzorp.net. So this is the same email address I used when I created the GitHub account. and it tells me I don't have Git, and here's the command to install it. So I'm going to do that next, sudo apt install Git, and it will install. And then I'm going to call back my previous command and try it again. And now I'm ready to do the second config line. Config global username, and this is my name. So these things are used when you send updates to the Git website, so it knows who sent them. Next, after we've done our two config lines, we're going to make sure we're still in our home directory, that we haven't accidentally changed out of it. So we're going to run cd by itself to make sure we're in our home directory. We're going to use the git command to clone our repository, to make a copy of it on our own disk. So we're going to say git clone https://github.com/our GitHub username. So I just called mine comp 2101 Wednesday slash, and now the name of the repository we want from that GitHub username, and the repository I made was called comp 2101. Because it's public, anyone can get a copy of it, so it simply copied it. If it was private, it would have asked me for my GitHub account password. On a public repository, anyone can get a copy of the files, but only the owner of the repository can send changes to it by default. Okay, so you don't have to worry about someone else messing up your repository when it's public. You only have to remember to put in your password when you send updates to it. I'm going to recommend, for our purposes, we're not creating anything sensitive here. Public is just fine. If you really want to play with the private, you can. It does mean that when the time comes for me to review your work, if you're showing it to me on GitHub, I will need you to add me to your GitHub list so that I can see your files. Having cloned it, if we use ls to see what files we have, we'll now find that we have a folder on our Linux disk called comp2101. In that folder is a copy of whatever files are on our GitHub site in the repository. Now, in this repository, when we created it, it actually made a file called readme.md. That's our document that shows up by default on the web page. So I would expect this file to be in my comp2101 folder on Linux. And indeed, if I change directory to comp2101 and list my files, there's the README file, the one that's on the website. So I have copied my repository. If there had been 500 files in the repository, there would now be 500 files in the copy on my Linux disk. Now, if I make changes to the files that are on the Linux side, they don't automatically show up on GitHub. I have to choose which ones I want updated and when. So we don't have complete chaos happening out there. Okay, you're still in control of it. It's not a cloud account like what Microsoft OneDrive or Google Drive or Apple iCloud is. It's not a mirror. It's two separate spaces to work on something collaboratively. Okay. All right. In that comp2101 directory on our local disk, we want a bash folder, a bash directory. That's because we're going to be creating bash and PowerShell throughout the semester, and you want to be able to put both of them in your repository. So we'll create separate folders so we don't wind up mixing the two files together. The instructions say make dir comp2101/bash, but this is of course assuming that you're in your home directory. The instructions didn't tell you to change anywhere. I actually did change somewhere, so I need to go back to my home directory if I'm going to use that exact command. So I've made a bash folder under comp2101, and that's where I'll be putting my files. All right, we're all set with our GitHub. We're now ready to start Atom back up and attach it to our GitHub files. So let's start Atom. I pinned it to my taskbar, to my launcher, so I can go ahead and just click it. And again, I need to wait until it's fully started up. I'll know when it has started up because the orange dot will show up beside the icon to show me it's running. Since I got rid of all those starter tabs, it has started with one empty untitled tab. I don't actually need that one. I could get rid of it. I'm going to leave it alone for the moment. Okay, we're going to choose Add Project Folder from the File menu. And in the pop-up it gives us, we're going to choose home username, whatever our username was, comp2101. So File, Add Project Folder. We're getting a pop-up. We're going to go to Home, our username. Mine's Dennis. We're going to go to comp2101. We're not going to open this. We're just going to pick it to select it. And this is the only window in the whole world that has the OK button in the top right instead of the bottom. So click OK in the top right after selecting comp2101. And you should get a drop-down list that says, here's the projects that we have going. We have a project called comp2101. And in there was that README file and our bash folder. If you did this step already by working ahead and you don't see these things showing up, right-click on whatever you have here and choose Remove Project Folder. It will not remove your files from the disk. It just takes it off the project list in Atom. And then you can add the project folder again, adding it correctly, if that's an issue anybody has had. Some people have that pretty much every semester. All right. Click on the comp2101 folder. We should see the bash folder underneath it. Okay. Right-click on the bash folder and choose New File and call it Hello World SH. So I'm going to right-click on the bash folder to get a menu. I'm going to choose New File, and I'm going to call it Hello World.sh because I'm going to make my first shell script. By convention, we name our shell scripts whatever we wish, and we put .sh on them as the extension. Linux doesn't care what you call a shell script file. The .sh is for tools like Atom, so they know that what's in this file is a shell script and not a JPEG or Word document or something. So I'll put in that name and I'll press Enter. Remember I said that the linter shell check that we installed has dependencies, extra packages it needs, and that the first time we opened a shell script, it would ask us to solve those? Well, that's exactly what's now happening. So I'm going to say yes to install this dependency, and I'm going to wait for it to finish, because when it's done, it's going to tell me there's other dependencies as well. The first time I open them. Yeah, it's not going to come up right now. That's fine. We can live with that for the moment. Solve that in a moment. So this is an empty file and it shows up. Installing dependencies Atom wants. That's fine. We should be seeing warnings right now in the status bar on on the bottom left. So that's down here in our Atom window, and we aren't seeing any warnings, which tells me it doesn't have all the dependencies yet. So what we're going to do is quit this tab that has the empty Hello World shell file. That doesn't get rid of the file, it just gets rid of the open tab. If we click the arrow next to the bash folder, it'll show us the files in there, including our Hello World, which is an empty file. If I just click on it once to open it, it will open our file. Okay, so that's how we can get back files to work on. When we're done working on a file, we can simply quit the file. When we want to open it, we single click on the name in the list and it opens it back up. Now it should be installing more things for that linter. It's not doing it automatically. So I'm going to try to force it. And unfortunately, this does happen from time to time. I'm going to quit this, and I'm going to quit Atom completely. I'm trying to make it recognize that it didn't finish installing. So I'm going to start Atom again, and hopefully the startup will make it recognize it didn't finish last time. And exactly that has happened. It says, hey, we didn't finish installing. I'm going to say, yes, please finish. And it says, hey, there's more. And we say, yes, keep going, install these tools. As I say, the installation procedure for this tool is cranky at best. It's not very impressive at all. The good news is the tool itself works very, very well once it has been installed completely. It's really important to get it to finish installing. If we now click on the Hello World to open it, we see it's there, and we see something down here that we didn't see before. This is what I was looking for. Linter errors. So these are coming from our plugin, and they would tell us if there was problems with what we've put into our script. And of course, we haven't put anything in our script yet. It's empty. Okay. So the first line of our script should look like this. We have our status bar. It is there. We're going to use the editor in it to create our script. We're going to be putting 2 lines in it. And the first one is this one. Hash, exclamation mark, what we call bang. These 2 characters together are sometimes called the shebang. And the name of the program that runs our script. It needs to be exactly like it shows here. So this should be hash bang / bin / bash. Now, as I type this, you can see that Atom is suggesting to me, oh, I maybe should type this a different way. I'm going to say, yes, thank you very much. I don't want to. If I press enter, it's going to put in its suggestion, and that's not what we want. So I'll use my arrow keys to just move around so it takes away the suggestion. Now, since I've been typing, the other thing that has happened is there's a blue dot that has shown up in the top of the tab. The blue dot means I have made changes that I haven't saved. If I quit this tab, that stuff I just typed in won't be saved in the file. I have to tell it to save when I want to. So it doesn't save until I'm ready. So that's the first line for our file. Now we need to put in our actual command, the thing we want our script to do. And since all we want our script to do is print out hello world, we need a command that will do that. Now I've given the command to you, but when you're creating scripts, just as a general rule, what is a common method for doing this is to figure out the command, test it, make sure it works, and then put it into the script. So for me to test a command that says hello world, I'll go to my terminal and I will put in my command that I think will do the job I want, and I'll run it. and I'll see that, yes, that command works. It says hello world, which is what I want my script to do. So that's the command that I need for my script. Okay, my script has been entered. Save your file. You can save the file a number of different ways. You can go to the File menu and choose Save, or in the window, you can do Control S. Either way, the little blue dot should disappear from the tab to say that the file has been saved. You'll notice the syntax has now been colored and highlighted to show what kinds of things are in here. There's gray to say this is considered to be a comment. There's blue for my command. There's green for what we call literal text in the command. In other words, Adam is trying to give us hints about what it is we have in our script. It can be very helpful to have this stuff. If I had a second command like ls in my script, and I had forgotten to type my closing quotation mark, you'll notice I've got some red dots and the ls is in green text. In other words, it's trying to warn me, hey, something's wrong here. When you look down at the bottom, you can see there's a little red thing here that says you've got 2 errors. And if I were to click on that, it'll even try to tell me what the error is. Couldn't parse this double quoted string. There's something wrong with your quotes. And yes, indeed, there is. So I'll undo what I put in there that was wrong and go back to having just what I wanted, and I will save my file again since I've made changes. All right, so we have our file. The instructions tell us the Git panel on the right should show our hello world as an unstaged file. Now, that might be a little confusing because we look at this and say, what Git panel? Well, there's a couple of buttons on the bottom here. The very last one here is Git, and it has a 1 beside it saying there's one change that we've made. If we click that, it's going to show us the details. So this is the Git panel we're talking about. That's not from clicking GitHub, it's from clicking Git. We want to see the Git tools. It's getting a little crowded. I'm going to make my window a little bigger so I can see it better. So the way that Git works, we made a repository to hold files. We made a copy of the repository on our local disk. And on our local disk, we've been making some changes. We made a folder for bash. We made a file in the folder. We made changes to the file. Those are all only on our disk. If we were to go to the GitHub website and look, we would not see that file, even if we refresh the page for our repository. Still only has the README file. So the general workflow is, you'll get the original files from GitHub. We've done that with our clone. We don't have to keep cloning. You create and modify things locally on your machine. When you're done making changes to a file, you take it from unstaged to staged. You can do that by right-clicking the file and choosing Stage, or you can choose Stage All if all of the unstaged files are ready. I'll pick Stage All and has moved it here. If I'm working on one file, this is very simple and straightforward. If I was working on 10 files, I can kind of tell by looking at which one, at this list, which ones are done working on and which ones I still need to work on. Okay. When I have all the files I need done and they're all staged, it's time to send that up to GitHub. The way to lock in my list of changes is to create a message here under commit message that describes why did I change these files? What did I do? If it's one file, it's usually pretty simple. If I changed a bunch of files, I may well have a longer message. Added this new feature to the software, fixed these bugs, whatever it was that I made these for. In my case, I created file for lab 1. That's what I did. So this is an English human description of what you did. If you went in there and changed line 6 from the word echo to echoed, don't put that as your comment, changed line 6, okay? That doesn't mean anything to anybody. Putting in there saying, oh, corrected the text to say the correct thing, that's what you want, okay? If your unstaged window doesn't show the file you've been working on, chances are you haven't saved it. So you have to save it. If you have, you should see it in green on the list on the left saying this has been changed since the last clone, and it should be showing up in unstaged. Once it hits unstaged, you move it to staged. From staged, you put in your comment and click commit. What that does is it kind of locks in your changes. Chris, I see your comment. I'll come back to you in a moment. This is our commit with the comment. If for some reason I say to myself, oh, wait a minute, I forgot something, I can undo this and put it back to staged. And if necessary, I can even unstage the file to go work on it some more. This one's done though, and I need to send it to GitHub. So just to complete the workflow, what I'll do now is I've got this thing that has to be sent. And the way that you send things is there's a button here called push. This one showed up when we committed to master. So you got to kind of do these in the right order. I'm going to click push. It's going to try to send it, and it's going to say, okay, what's your GitHub login? What's your password? So my GitHub username was comp2101 Wednesday. And now it wants my password. I have no idea what it was. I face rolled my password. So I'm going to go to my Firefox where it saved it. I'm going to go to my logins and passwords. I am going to take my only saved password. I'm going to copy that. I'm going to go back here. And I'm going to try to paste it. And I'm going to check the box to say remember, so it doesn't ask me for this login every time I try to push a change. And it will send the change to GitHub. When it's done, the push goes away. It just says fetch. It's a way of checking if anything's different. Okay? So this is all in the instructions. It says choose your stage, put in your comment, click your commit, click on push, put in your username and password, and we should be all set. And you'll notice we're all set because the Git shows 0 changes remaining, which means if we go to the GitHub website and refresh our page, not only do we have a README file, we now have the bash folder from our local disk on the website. And if we go in there, we have our hello world. And if we click that, there's our file. So we've managed to successfully putting it there. Chris, I see your comment. Good. I'm glad you got it solved. All right. So just to do a quick recap. When working with things from GitHub, normally what we'll do is copy our files down from GitHub if we don't already have them. We'll make changes locally. When they're complete, we'll stage them, we'll commit them, and we'll push them, at which point they're on GitHub. Now, GitHub is designed for collaborative work, which means other people may be doing this as well. And at any given time, there might be changes on the repository on the website that you don't have on your local disk. Maybe you didn't create them, or maybe they were created on the website. So let's take a quick look at how do we get those to our machine. Well, first we need to have different files on the website. The easiest way is we'll start with our Hello World file, and we'll click the little pencil that lets us edit the file right on the website. So I've clicked the pencil, and I now have an editing window, and I could put more lines in. I don't really want to change what my script does, so I'll put in something harmless. I'll type in exit to say, well, when we're done our script, we'll exit the script. So we're going to add a third line that says exit. Now, there's no staging when you do this on the website because it's already on the website, but we do need to commit it. So this is where we would put our comment. The default says update the file. That's fine. I'll just leave that alone. And I'll click commit. So now the copy of the file on the website repository has 3 lines in it. My file on my own disk has only 2 lines in it because I am now behind the master copy. Somebody else has done some work in the repository and I don't have their work yet. Okay? So to get myself updated, I need to go into Atom and tell it, take a look. Or I could go to the command line to check and see. Okay. We need to wait a moment or two because GitHub is a global website. It has millions of users. And when you do a commit, it can take a little while before that actually is saved and recognized. Okay. And I know we're 1 or 2 minutes over our time limit here. If you hang around for a minute, we'll all be done together. If the change doesn't automatically show up, if this doesn't turn into a pull saying there's a change to bring down, at any time you can click fetch. And if you do that, it will tell you if there's things to pull down from the website. Mine's changed to pull, saying there's something to bring down. So I will click pull, and it will get the new files. And not only did it get them, but you'll notice the editing window automatically shows I now have 3 lines in the file because now I am synchronized again with the master copy on the GitHub website. Okay? Using this tool will help you to become familiar with the details of it. It can be a very helpful little tool. If for some reason you find it to be onerous or difficult or not of use to you, you are not required to use it past today's lab. You have to get today's working, okay? After today, it's up to you if you want to use it to make life easier. If it doesn't make your life easier, don't use it. Just do all your work in the command window. Now, since we've made a script, the last thing that we're going to do today, just because we made a script, is run it. Okay, we have everything kind of working. Let's go ahead and run it. Let's go to our command window and go to our bash folder. Let's set the permissions on our script and let's run it to make sure it actually works. So in our terminal window, we're going to change directory to our home directory /comp2101/bash. We're going to change the permissions to add execute on hello world. And we're going to run hello world by typing in /hello world. And it should say hello world, and that's our reward. We have our very first script working and saved on the internet. Does anybody have questions about what we've done here? In the chat would be best. Craig. I'm going to chat with you briefly once we get past everybody else because yours is a VM issue. Chris, great. Thank you. All right. Unless you need help with something, we are done for today then. And look at that cheat sheet. Do the bash commands quiz. Get your 75% so things open up. And make sure you get your lab system set up by the next week because we're going to be going forward from here next week. Again, if you don't need ongoing assistance with something, you can disconnect at any time and all good. Craig, I'll help you with your issue first. If you could share your VM with me, I can help you resolve that. Jilang, I don't know if I've said your name correctly, Jilang Yu. If you give me a moment, I can have a look and see what's going on there.